In this video, we're going to look at solving simultaneous equations. Now, before we have a look at some specific examples, we're going to consider what simultaneous equations are generally about. Now, you probably know how to solve simple equations like this. Let's say I have 2x plus 4 and that equals 13. Well, we've got here one equation and one unknown, and we can solve this through a series of steps. We can subtract 4 from the left-hand side and the right-hand side. That would give me 2x equals 9. And then I can divide the left and the right by 2 to give me x equals 4.5 or 4.5. Now, that's great. But what if we had a different type of equation where instead of having just one unknown, x, we had two unknowns? I'm going to use x and y, but I could use any letters I liked. Doesn't really matter. So let's go for something simple like x plus y equals 10. Can we solve this equation? Well, yes we can, but the problem is there are infinitely many solutions. For example, it could be that x is 10 and y is 0. That would work. If x was 10 and y was 0, 10 plus 0, that gives you 10. So that's a solution. However, it's not the only solution. What if I had something like x equals 9, y equals 1? They add up to 10 as well. And we don't even have to stick to whole numbers. We could have x equals 0.5, y equals 9.5. We can get into negative numbers like x equals -3, y equals 13. So you can see how we actually end up getting infinitely many solutions to this equation. Now, that's not very helpful in a lot of cases. So, to recap, here we have one equation with two unknowns, and what we're finding is that it's impossible from this information alone to work out the particular value of x and y that add up to 10, because there are lots of possible pairs that we could have. And what if we're only interested in one particular pair? Well, for that, we need a bit more information than the original equation. So let's say I also told you that x minus y must equal 6. Now, we know that all of these solutions that we've written here are solutions to the first equation. These are values of x and y that satisfy the first equation. That means these values work in the first equation. But do they work in the second one? Well, for example, let's try x equals 10, y equals 0 in here. 10 minus 0, is that 6? No, it's not. So we know this is not a solution to the second equation. What about x equals 9, y equals 1? 9 minus 1 is 8. That doesn't work. And if you try the others, you'll see that none of these work. In fact, what does work is x equals 8, y equals 2. Now, this works for the second equation, but importantly, it also works for the first one. So this is the solution we're looking for. It is simultaneously the solution to the first equation and the second equation. We've got the values of x and y that work in both equations. And in this case, this is unique. There's no other way of doing it. For example, if I tried something like x equals 15, y equals 9, you'll find that these values satisfy the second equation. 15 minus 9 does give you 6. So these satisfy the second equation, but they don't satisfy the first equation because 15 plus 9 is not 10. So what we've seen here was an example where when you had one equation with two unknowns, we didn't have enough information to pin down the value of x and y. But given a suitable second equation, we now had enough information to pin down exactly what x and y are. And this video is about how to solve simultaneous equations like this. That means finding values for the unknowns that satisfy both equations at the same time. Let's start with the first one. We have 9x plus 2y equals negative 43 and 5x minus 2y equals 1. Now, this is a relatively easy question because what we've got in this case is a pair of coefficients of one of the unknowns that are equal but opposite. So let me just be clear what I mean by that. In this example, we've got 9x plus 2y, and in the second one, we've got 5x minus 2y, and these add up to 0, essentially. Plus 2y minus 2y is just 0. And that's really handy because what we can do is add these equations together. So if I've got the first one, 9x plus 2y equals negative 43, and then the second one, 5x minus 2y equals 1, I can add the two equations as follows. On the left hand side, I'm going to get 9x plus 5x to give me 14x. I'm going to get 2y plus negative 2y to just give me 0, so I don't need to write anything here. And that's going to equal negative 43 plus 1, which is negative 42. Now, some of you might be thinking you're a bit uncomfortable with this idea of adding equations, so let's have a look at why this makes sense. For now, let's just focus on adding negative 43 and 1. Forget the rest of the equation. Those are just two numbers, and you should be happy about adding two numbers together. Negative 43 and 1 add up to negative 42. But wait a minute, we know that negative 43 is worth 9x plus 2y. Whatever those are, negative 43 is equal to that. And we also know that 1 is worth 5x minus 2y. Again, we don't know what x and y are, but we know that 5 lots of x minus 2 lots of y is worth 1. So if I add the green and the yellow quantity together, and that's negative 42, well, the green and the yellow quantity over here should also add together to be 42. And when I add 9x plus 2y to 5x minus 2y, I'm going to get, when I collect the like terms here, 14x plus nothing, because the plus 2y minus 2y cancel out effectively. So that's why I can say 14x equals negative 42. I can simply add the equations together. Now we can carry on. 14x equals negative 42. So to work out what x is, I need to divide the left-hand side by 14 and the right-hand side by 14. So on the left, I just get x, and on the right, I get negative 42 divided by 14, which is negative 3. So we've worked out the value of x. But remember, we've got two unknowns. We've got x and y. So it's not enough to just stop there. We need to also work out the value of y. And we do that by substituting in this value of x into one of these equations. Now, as long as we've got this right, it doesn't matter which one we substitute it into. I'm going to substitute it into the second one just because it's got a smaller coefficient of x, so I'm going to be dealing with some smaller numbers. So if x is negative 3, what that means is I've got 5 lots of negative 3, which is negative 15. And then I need to subtract 2y, and that should equal 1. What I can do next is add 15 to the left and the right hand side. So if I add 15 to negative 15 minus 2y, I'm just going to end up with negative 2y. And if I add 15 onto the right hand side, I'm going to get 16. And what I get next then is y equals negative 8. I've simply divided the left hand side by negative 2, and I do the same thing to the right hand side. So I've got x equals negative 3 and y equals negative 8, and together that gives me the solution to this pair of simultaneous equations. So I'm just going to write that here. X equals negative 3, y equals negative 8, and that is the solution we are looking for. Let's move on to question B. In question B, we've got x plus 8y equals 60 and negative x plus 6y equals 38. Now, this is also a relatively easy question because if we add these equations together, you will see that we have the x's eliminating. Now, in the previous example, when we added those together, we had the y's eliminating because positive 2y add negative 2y gave me 0. In this case, I've got 1x and I've got a negative 1x. So let's see how this works out. We've got x plus 8y equals 60. We've got negative x plus 6y equals 38. And when I add x to negative x, they eliminate. I get 0. When I add positive 8y to positive 6y, I get positive 14y. And when I add 60 and 38, I get 98. So, just like before, what we've done is add together two equations in such a way that we eliminate one of the unknowns. In this case, I've eliminated the x. So I can now solve this to find out what y is. Dividing the left-hand side by 14, I just get y. And 98 divided by 14 is 7. So we know that y equals 7. But remember, we're not done there. We need to find values for x and y. So we need to substitute this into one of the equations. If I substitute it into the first one, what I'm going to get is that x plus 8 lots of y, so that's 8 lots of 7. That's 56. That must equal 60. And we can see from here that x must therefore be 4. So x equals 4 and y equals 7 is our solution. Now, what you should really do when you get your solution is check those values work in the other equation, the one that we haven't just used. So we can substitute these into the other one and make sure that they satisfy the second equation. Negative x in this case would be negative 4. Remember, if x is 4, negative x would be negative 4. So we'd have here negative 4 plus 6y, or 6 lots of y is 6 lots of 7 in this case, so that's 42. And negative 4 plus 42 is indeed 38. So we know that those values satisfy the second equation. So we've solved this set of simultaneous equations. X equals 4, y equals 7. Let's move on to part C. This time we've got negative x plus 5y equals 16 and negative 3x plus 5y equals 18. Now, adding these together won't actually eliminate one of the unknowns. If I add negative x to negative 3x, I will get negative 4x. And if I add positive 5y to positive 5y, I'm going to get 10y. And that's no good. Remember, what we want to do is eliminate one of the unknowns, because that will then help us work out what the other one is, and then we can use that to work out what the first unknown is. But it's fortunately quite easy to do in this case. Notice that we've got equal values of the same sign here. We've got 5y and 5y. And what we can do is easily change that around by multiplying one of the equations through by negative 1. Let me demonstrate what I mean. So in this particular case, I'm going to, let's say, keep the first one the same and multiply the second equation through by negative 1. If I multiply all of this through by negative 1, well, negative 1 lots of negative 3x becomes positive 3x. Negative 1 lot of positive 5y becomes negative 5y, so I've got 3x minus 5y, and that equals negative 18. Remember, if I'm multiplying through by negative 1, I need to multiply both sides by negative 1. So now I've got negative 18. Because we've done the same thing to both sides of this equation, this is still a valid equation. If this is true, then so is this. But now you'll notice we've got plus 5y and minus 5y, which means when we add these equations together, the y's will eliminate. By the way, if you're wondering why I chose to multiply the second equation through by -1 and keep the first one the same, and whether I could have done it the other way around, the answer is yes, it didn't really matter. I could have kept the second one the same and multiplied the first one by -1. I actually chose to multiply the second one through because now when I add these together, I'm going to have -x plus 3x, which gives me positive 2x. And I just thought a positive coefficient of x would be easier to work with. If I did it the other way, I would have ended up with a positive x and a negative 3x being kept the same, which would have added together to give me negative 2x. So that's why I chose to multiply the second one by -1. Anyway, adding these together, I've got my x's added together. The 5y and the negative 5y eliminate each other. And that means 2x equals 16 plus -18, which is -2. Now, if 2x equals -2, that means x equals -1. So, we've got the first part of our solution. We know x equals -1. To find the value of y, we need to substitute that in to one of these equations. Let's substitute it into the second one. Again, it doesn't really matter whether I go for the first or the second, I'm just choosing the second. -3 lots of x, so that's -3 lots of -1, that's positive 3, plus 5y, that equals 18. Subtracting 3 from both sides, we get 5y equals 15, and that means we get y equals 3 because we can divide the left-hand side and the right-hand side by 5. So we've got x equals -1, y equals 3. And because we just used this equation to work out the value of y, let's check that we've got this right by substituting both values into the first equation. So negative x is going to be -1, which is simply positive 1. And we're going to add that to 5 lots of y, 5 lots of 3, so that's 15, and 1 plus 15 does give me 16, so we know we've got that one right. So there we have it. Our solution to this set of simultaneous equations is x equals -1, y equals 3.